All right, let's take a look at your CFU for 7.1.3. So factoring out common factors and factoring trinomials where the leading coefficient is something other than 1. All right, I'm just going to do something real quick here. Sorry if it looks kind of weird. My alignment was not off track here. So it says factor each expression. So these first few examples, at least the first 6 here, are like what we did on the front page of notes. We're looking for what factors do they have in common. So 5 and minus 30, they share a 5, goes into both. X squared and x, they share x. So what am I left with? I'm just left with x and a minus 6. I can check. 5x times x is 5x squared. 5x times minus 6 is minus 30x. That one looks right. All right, next one. So this one I want to look at what they all have in common. If I look here, they all have a 3 in common. So I factor out the 3, left with x squared plus 4x plus 3. Trinomial, factors of 3. Do they add up to 4? 3 and 1 does add up to 4. So this factors to x plus 3, x plus 1. So I have 3 on the outside, x plus 3 sets of x plus 1. Of course, I can FOIL and check to make sure I get this, and then distribute the 3 and check, and it should give me 3x squared plus 12x plus 9. All right, next one here. 6 and 54, they share just a 6. So I have x squared minus 9. Difference of perfect squares. So I have x plus 3, x minus 3. With the 6 on the outside. So through a couple of them right away where you actually had to factor out more than just one step. That can happen. All right, the next one here, look at what we have. Both have negative in common, and notice how they both have an 8. How many x's do they share? X squared. So I'm just left with an x, and then this becomes a plus 3. Do a quick check. Negative 8x squared times x is negative 8x cubed. Negative 8x squared times 3 minus 24x squared. That one looks good. All right, next one. Looks like they all share just an x. So x squared plus 8x plus 12. Right away I'm thinking factors of 12 that add up to 8. I think we've seen this one before. 2 and 6. So I have x on the outside. X plus 2 times x plus 6. Just like that. We're cruising right along. Next one. Factors. Let's see. 9 and 81. They share a 9. And they both share x. I'm left with x squared plus 9. That's a plus. So it's technically not a difference of perfect squares. So I can't factor that one any farther. All right. So that takes care of the ones that were on the front page of the notes. On the back page of the notes, these were the more challenging ones. So let's take a look at how we deal again when we got leading coefficients other than 1 in front of the x squareds. So again, how we like to approach this problem. We first take the first and last term and multiply them together. So 2 times 7 is 14. So now I'm looking at factors of 14 that add up to 9, which happens to be 2 and 7. Sometimes they can be that easy. Other times you might have a different set of factors. So what I can do is rewrite this 9x as 2x plus 7x. Doesn't matter which one you write first or second. In the end, you'll get the same answer. All right, so now I bring down the 2x squared. I bring down the 7. And now I'm going to factor by grouping. Meaning, group the first 2 terms together, ask myself what they have in common. They share a 2x. So I'm left with x, and I'm left with a 1. When I pull out everything, I always have a 1. Look at what they share. They just share a 7. 7 goes into 7x x times. 7 goes into 7 one time. This works out beautifully if these two are exactly the same. So in the first set of parentheses, I have 2x plus 7 sets of x plus 1s. Okay, so I'm just taking 2x sets of them, and I'm adding 7 more sets of them. So I have 2x plus 7 sets of x plus 1s. All right, that one is done. All right, same process. Multiply the first and last term. So let's see, 3 times negative 2 is negative 6. I want two factors of negative 6 that add up to negative 5. Now some of you might be going, oh, just do 3 and negative 2. Those actually add to positive 1. In this case, I actually have to go minus 6 and plus 1. So I'm going to break up that negative 5x as minus 6x plus 1x. Okay. So I'll put 3x squared and minus 2. So now, factor by grouping. These two share a 3 and an x, and I'm left with x minus 2. When I look at these two, they don't share anything other than a 1. So I can still write plus 1, and I have x minus 2's. Notice how, as I did that, those are exactly the same. So I combine the outside, so I have 3x plus 1 sets of x minus 2's. All right, last problem here. So do the crisscross. Multiply A and C together, so 5 times 2 is 10. Looking at factors of 10, that add up to 7. This one's kind of nice again because it really is 5 and 2. They add up to 7. So I can rewrite that 7x as 5x plus 2x. Bring down 5x squared. Bring down the 2. All right, so now let's factor by grouping. Group the first two together. They share a 5 and an x. Left with x plus 1. 2x and 2. They share just a 2. Have x plus 1. Because 2 goes into 2x. X times 2 goes into 2 one time. All right, so notice how they are exactly the same. X plus 1, x plus 1. So I have 5x plus 2 sets of x plus 1's. All right, so that takes care of the CFU page. So let's move on to the assignment page. So it says factor each expression. So make sure you factor it all the way if you can do so. All right, so I'm going to look at the first one here, and I ask myself, what do they share? Looks like a minus 3 and an x. So when I pull out a minus 3 and an x, I'm left with x squared, and I'm left with a plus 11. Can't do anything more with that, so I have that first one done. Ooh, look at the second one. They all have a 2 in common. When I factor out the 2, I have x squared minus 20x plus 100. So factors of 100, if I think about this, factors of 100, that add up to minus 20, both are negative 10. So x minus 10, x minus 10. Got that one done. Sweet. Moving right along. 4x squared plus 9x, they only share a x. So I'm left with 4x and a 9. They don't have anything else in common, not perfect squares or anything. So that one's all finished. Next one here. Let's see. They just share a 5. Left with x squared minus 4. Ooh, perfect square, difference. Difference of perfect squares. So it's taking into account all the stuff I've learned before. Oops, I almost made a mistake there. X plus 2, x minus 2. And I'm good to go there. Ooh, next one. They all share a 2. So I have a 2 on the outside. X squared minus 2x plus 1. This one's kind of interesting. Factors of 1 that add up to negative 2. They're both negative 1's. So I have 2 x minus 1 times x minus 1. All right. Let's see here. Continuing on. 2x squared plus 2x plus 84. Ooh, they share a 2. So I have x squared plus x minus 42. Ooh, we've had this one before where we had a factor of 42, and they differed by, I think, a positive 1. 7 times 6, but I got to make one of them negative. So I'm going to make the 6 negative, so I get the positive 1 when adding them. So x plus 6, x minus 7. Woo. All right. 6 down, I think 8 to go. All right, they share an x in common. So I'm left with x squared plus 8x plus 15. Ooh, factors of 15 that add up to 8. We've done that before. 5 and 3. So I have x plus 5 times x plus 3. All right, next one here. They share a 4 and an x. So when I pull it out, I'm left with x and minus 6. That's all. 4x times x is 4x squared. 4x times minus 6, minus 24x. So I just did a quick check there. Number 9, let's see here. 14 and 24. They share just a 2. X to the 5th, x to the 4th, they share x to the 4. So I'm left with just a 7 and an x and a minus 12. So just I could do a quick check. 2 times 7 is 14. X to the 4th times x is x to the 5th. 2 times negative 12 is that minus 24. X to the 4th. All right, let's see here. Number 10. Let's see, they share a 3 and an x. I'm just left with x plus 3. So 3x times x is 3x squared. 3 times 3 is 9 with the x. Oh, that wasn't too hard. All right, next one. Looks like they share an 8 and an x. So x squared minus 4. So 8x, x plus 2, x minus 2, difference of perfect squares. There we go. All right. Ooh, number 12. We finally get to ones like the back page. I'm going to slide this up here just a little bit, just to make it a little bit easier for me to do. Okay. So, again, with this one, I'm multiplying the first and the last. Factors of 45 that add to negative 18. Let's see. So factors of 45. This might take a little while. 1 and 45, 5 and 9. Those don't work. Ooh, 3 goes in there 15 times. There it is. Minus 3 and minus 15. So if I break this up, it's like saying minus 3x and minus 15x is another way of saying negative 18x. I have 5x squared in the front, and I have 9 at the end. So now let's factor this by grouping. See, 5x squared minus 3x, they only share x. So I'm left with x, 5x minus 3's. When I factor this one, they share the negative, and I can factor out a negative 3. I'm left with 5x. Notice when I factor out the negative, it actually makes it a negative 3. Notice how they're the same. Now I can put these two terms together, x minus 3, sets of 5x minus 3's. Again, I can always FOIL this. X times 5x is 5x squared. I have minus 3x minus 15x. Notice how that's those values right there. Give me my negative 18x. Negative 3 times negative 3 is 9. All right, let's take a look at our last two here. So when I look at this one here, 36 and 63, they share the number 9. They also share x. So let's see, what do I have left? 4x. 9 goes into 63 7 times. I pulled out the x. That one I am good to go. All right, let's see here. I'm just going to extend this page just a little bit. There we go. All right, so on the last one here, as I do this one, I got to multiply the 2 together. So 3 times 2 is looking at multiples of 6 that add to 5. This one's actually nice because that's really just 3 and 2. So I can rewrite this 5x as 3x plus 2x. So very similar to a couple examples we did in the notes, or actually in the CFU I think we just did. So now I'm going to factor it by grouping. So as I group the first two here together, they share a 3 and an x. So I'm left with just the x. 3x goes into 3x one time. Then I group the second grouping, 2x and 2. They share a 2 in common, and I'm left with x plus 1. So I have 3x plus 2 sets of x plus 1s. Of course, I can FOIL that out and check just to make sure it works. All right, that takes care of your CFUs and your worksheet for this assignment. We'll see you on the next set of notes.